Section 6-7 is about polygons in the coordinate plane. And what we will do is take coordinates and plot them and determine if the polygon formed by those coordinates is a rectangle or trapezoid or a kite or different types of quadrilaterals or types of triangles. Okay? And by the end of this section, I hope that you can use the distance formula to find the distance between points. Use the midpoint formula to find the midpoint on a segment, and use the slope formula to find the slopes of segments. We'll talk about those formulas in this first video. In the second video, we'll talk about how you can determine if a triangle is scalene, isosceles, or equilateral when you're given the coordinates of its 3 vertices, and if you can determine if a quadrilateral is a parallelogram, rhombus, rectangle, and or square, or kite, or trapezoid when you're given the coordinates of the 4 vertices. Okay, first, the distance formula. Now, this was a section that we skipped in the first chapter, and I did that because I wanted to discuss it more when we hit the Pythagorean theorem, which is still coming up in future chapters. But we have to use it in this section. So even though I've put it off, we have to discuss it now because we need to use this in this section. Okay, so we'll talk about how to derive it and where it comes from later on in the year, but we'll just kind of use this as a formula, and you probably have seen this in past math classes. But the formula is the distance is equal to the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. Okay, and the most common mistake I see students make with the distance formula is with negative signs. So be very careful with negative signs. Okay, I will call this x1 and y1, and this point x2 and y2. Okay, now I could, switch this ordering around if I wanted to. Okay, but I'll just keep it that way for simplicity. Okay, so the distance is equal to the square root of x2 minus x1 plus y2 minus y1 squared. Okay, the difference in the x's squared plus the difference in the y's squared, and take the square root of that. So 4 minus, I'll do the parentheses first. 4 minus 0 is 4 squared, plus 4 minus 1 is 3 squared. Now 4 squared is 16, plus 3 squared is 9. So we get the square root of 25, or 5. So the distance between these 2 points is 5. Okay, let's try a little more difficult problem. Again, I still have the formula written up there. I'll call this x1 and y1. Use a different color. x1 and y1, and x2 and y2. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so negative 2 minus 0 is negative 2 squared plus 0 minus 4 is negative 4 squared. Okay, now be very careful with negatives on this next step. Negative 2 squared, or negative 2 times negative 2, is a positive 4. Because a negative times a negative is a positive. Okay, whenever you square a number, negative or positive, it'll always be a positive number. Okay, plus. Negative 4 squared is negative 4 times negative 4, which is a positive 16. Okay, 4 plus 16 is a square root of 20, and I could simplify this, but I'll leave it as square root of 20, or you can find the decimal in your calculator if you wanted to. Okay, the midpoint formula we've talked about briefly in chapter 4, but I think of it as finding the averages between the x coordinates and the average of the y coordinates. So I'll call this x1 and y1, x2, y2. I'll find the average of the x's, add them together, divide by 2, and the average of the y's. So 0 plus 4 is 4 over 2. And 1 plus 4 is 5 over 2. Or simplifying even more, 4 over 2 is 2. And 5 over 2, you can leave it as 5 over 2, or if you prefer decimals, 2.5 would be with the decimal. Okay, and that's the midpoint, the middle of that of those two coordinates. The last formula in this first video is the slope formula. We talked about this back in chapter 3, but I'll call this x1, y1, x2, y2, and I'll plug it in. Again, the slope is the rise over the run, or the change in y's, or over the change in x's. Okay, so slope is equal to y2 minus y1 over x2 minus x1. 4 minus 1 is 3. 4 minus 0 is 4. So the slope between these 2 points, or the slope of this segment made by these 2 points, is 3/4. And that's the end of this first video.